Hello, everyone. Welcome back to Illuminate 2021. It's great to have you all with us on this session dedicated to application observability. My name is Paweł Brzoska, and I'm leading this part of Sumo Logic platform from product perspective. Together with our guest speakers from Pitney Bowes, Kulwant, who is leading their product support and monitoring strategy, and Derek, experienced cloud migration DevOps architect, we're going to deep dive into their experiences with modernizing Pitney Bowes application stack. We're going to talk about challenges it brings, as well as lessons learned throughout this journey, and Sumo Logic role in helping to resolve these challenges. Finally, we're going to update you on recent additions to application observability we have worked hard for you over past year. We'll be available in the chat to answer any questions you may have. This session, as well as any other, will be available for on-demand viewing on the Illuminate 2021 streaming platform until end of October. Without any further ado, I would like now to ask Kulwant to kick it off with Pitney Bowes application modernization start. Kulwant?
Thank you, Pavel, for having us here. Before we move into main agenda, let me briefly talk about Pitney Bowes and a little bit about the application that I'm managing with the help of Derek and team. So Pitney Bowes is a global technology company providing commerce solutions that power billions of transactions on a daily basis. Clients around the world, including 90% of Fortune 500, rely on accuracy and precision delivered by Pitney Bowes solutions, analytics, and APIs in the area of e-commerce fulfillment, shipment and returns, cross-border e-commerce, office mailing and shipping, pre-sort services, and financing. For over 100 years, Pitney Bowes has been innovating and delivering technology that remove the complexity of getting commerce transactions precisely right. For additional information, visit Pitney Bowes at www.pitneybowes.com. The component that I support is one part of ecosystem and have multi-carrier tenancy. Application has integration with most of prominent domestic carriers in the United States and also carriers who delivers to other parts of world too. Talking about API, it's mainly REST-based API. We have got into microservice architecture and it's multi-region for better availability. Application handle 10 plus million calls per day with efficiency to make shipping experience for our e-commerce clients fast and pleasant. APIs stays available 24/7 and 365 days a year to serve the need of our customers. QoS is an important aspect of our platform and consistently delivering 99.99% QoS. And the next goal is to have 5 nines. Performance is another aspect to make experience richer for our clients. To share platform can handle 1600 transactions per second and any native shipment label print call, which is the costliest call in terms of time, would be completed in approximate 250 milliseconds consistently. Now, did we reach here and accomplish this overnight? I know that won't be possible for anyone out there, and we are no exception too. Stack evolution happened for us in terms of technology, use cases, commitment to clients for SLA, and learn and implement approach. So modernization, if we talk about that, starting with moving architecture from SOA to microservice-based, migration on-premise to cloud, and then going serverless. Platform change from Windows and .NET to JE to Spring Boot and containers. And also with these advancements, we are not single language application, but polyglot. Full stack monitoring was another thing that we got involved into. TechOps team responsible for production monitoring owns the application and infrastructure as well. So not just application, AWS infrastructure like Classic DB, RDS, Beanstalk, EKS, and so on stays under close watch. Server level matrices like CPU, memory, network, in and out are top 3 matrices that we started monitoring. In early days, it was just API Uptime, which was our focus area. With growing business and increasing customer base, it was vital to have a tap on performance of API calls. That's where we started coupling application and infrastructure together. How did that help? Well, based on resource usage and API loads, setting a well-tuned auto-scaling policy was easy. So let's talk about the custom monitoring versus out-of-box monitoring options. So idea was to catch even customer side issues before they say, for example, spike in HTTP 400 responses or no traffic or dip in traffic based on last few data points. Implementation of trend monitoring in this way enabled us to detect and predict behavior in advance, irrespective of hour of the day. And in the end, ability to track each transaction from point it lands into application layer and exits, especially while troubleshooting any failed transaction. So that helped a lot. Derek will be talking about in some time to share more insight on the trace implementation. So let's talk about the challenges that we encountered for monitoring the new stack. Now, transformation is the key in today's world, but then there are challenges associated with it in terms of technology, human resources, time versus money, and the use cases. While we moved from legacy setup to containerization to Kubernetes, training operation team versus time to deliver or say go live date was one major challenge. Sticking to Sumo logic for monitoring EKS stack was taking one task away from me, and that was not to worry about training the team on a new tool. Delivering at time is critical, along with the readiness of operational part. One aspect is how comfortable other teams like developer, QA, and even BA are with an idea of introducing a totally new monitoring tool. Learning Kubernetes first and then on top of that, learning new tool was one thing that we thought we should be avoiding, keeping tight timelines for go live date, and that too without compromising on any functionality and features. We talked about high volume and QoS. Even a glitch could be sensed by customer almost instantly. Having too many tools and places for monitoring the whole system would have added delay in detection and tracing the issue. All these needs will definitely invite more costs, but optimization with custom configuration was on top of our agenda while getting the new stack productionized. Reliability and consistency was evaluated too, and that too without any overhead on operations team. With keeping all this in mind and a quick discussion with Sumo support team, we laid out path for going ahead with Sumo EKS and distributed traceability feature. With that, to talk more on implementation of distributed tracing, I hand over to my colleague Derek. Derek, over to you.
Okay, thank you, Kuwan. I would like to start by reviewing how we monitor our current application and infrastructure. I'd like to talk about some of the challenges and lessons that we've learned in adopting a new cloud-native Kubernetes-based microservice platform. Before describing how we monitor our application, I'll briefly mention several important aspects of our product. Our product is composed of a set of RESTful APIs that provide shipping functionality directly to external business partners, internal products within Pitney Bowes, and to developers through a public API gateway. As Kuwan mentioned, it is critical that we maintain the performance and reliability of our product. Our application runs in AWS and is deployed to EC2 instances, Elastic Beanstalk, ECS, and Lambda. This slide shows a screenshot of a dashboard that we use to monitor the application. As you can see, we monitor request counts, throughput, error rates, response time, and resource utilization metrics. These are all important to monitor in a traditional server-based application. This application has been running live in production since 2015, and our monitoring has helped us meet our SLAs and provide a great end user experience. This year, the team developed a new Kubernetes-based microservice platform. One of the challenges that we faced when building this platform was overcoming the Kubernetes learning curve. In addition to coming up to speed with new Kubernetes concepts like nodes, pods, and ingress controllers, the team had to learn how to build, deploy, operate, and monitor applications running in Kubernetes, as well as the Kubernetes cluster itself. One area in particular that was challenging for the team to come up to speed with was the Kubernetes resource utilization model. Understanding resource utilization and capacity planning are very important to our application because of our requirements for performance, availability, and cost. So as the team was developing the platform and learning about resource utilization in Kubernetes, we realized that we needed to adopt new tools to gain visibility into Kubernetes. This screenshot shows the type of dashboard that helped us visualize resource utilization of our application in Kubernetes and start to overcome the Kubernetes learning curve. This is another example of a dashboard that we found very insightful. It uses distributed tracing information to show how our application is performing in terms of latency or response time and error rate. This slide shows a dashboard that we use to tune the auto-scaling configuration of our application. Auto-scaling is very important to our application. Our application must maintain high levels of throughput with low response time and with the minimum infrastructure hosting costs possible. We need to be able to tune the auto-scaling of our application so that it scales up during times of increased demand and scales down when the load is low to minimize costs. As you can see from this in the previous slides, the first lesson that we learned in our Kubernetes journey was that we needed to adopt new tooling that would give us the visibility we needed to build and monitor our Kubernetes-based platform. The next lesson that we learned was how to navigate the Kubernetes open source landscape. This is a slide from the Cloud Native Computing Foundation's observability and monitoring landscape. As you can see, there are many different components and solutions available from the open source community. It would be difficult to plot a course through this landscape, especially for a team that was new to Kubernetes like ours. Another challenge for our team was that once we had chosen a monitoring solution, was to implement that solution. Monitoring solutions for Kubernetes, like Kubernetes itself, can be complex. So our team dealt with this complexity in a couple of different ways. The first was we leveraged experience from other parts of our organization. We leveraged the knowledge and guidance from other teams within Pitney Bowes that had already been using Kubernetes. Another way that we navigated the open source landscape was with the help of Sumo. They provided the support we needed to configure and deploy an open source based Kubernetes monitoring solution. So the main lesson here that we learned was to anticipate the complexity and learning curve of an open source cloud native application and its monitoring, and have a strategy to deal with that complexity. Next, I'd like to talk a little bit about our journey of using a service mesh and distributed tracing. As we began developing our microservice platform, we wanted to use the traffic management, security, and metrics capabilities of a service mesh. We also want to use distributed tracing to get visibility into the timings of transactions in our system. These timings are very important for us to be able to tune our system, its performance, and monitor the performance. So we believe that this combination of service mesh and distributed tracing would make it easier to get the visibility into the performance of our system that we needed. To explain why we were interested in this approach, consider a simple way to measure performance without distributed tracing. This slide shows some example Java code that logs the time it takes to process an order. Almost every developer has written code similar to this. This code works, but it is tedious to write, can change frequently, has to be duplicated when adding new functionality, and is unstructured and not easy to analyze. to analyze. Using OpenTelemetry auto instrumentation, we were able to eliminate most of this type of code and thus simplify our code base. This slide shows a trace from our application after implementing distributed tracing. Using the OpenTelemetry as auto instrumentation feature, we were able to get visibility into the timings of our transactions, including database calls, external APIs, and the time taken by each of our microservices. And we did all that without having to write a ton of logging code. So some of the challenges we faced with distributed tracing and our service mesh were how to properly configure propagation of tracing headers from our service mesh and properly filtering out non-value-added traces related to health checks. So as I mentioned, one of our objectives for using distributed tracing was to gain visibility into the timing of the microservices in our application. An additional benefit of using distributed tracing in the Sumo Logic solution is that they can analyze the tracing data to provide more in-depth visibility into the application. This slide shows the service map feature in Sumo Logic, which is able to analyze the tracing data and detect the connections between our microservices, internal components such as the Istio ingress gateway, databases, and external APIs. This capability helps us to visualize our microservice architecture. So to summarize, I'd like to highlight some key takeaways from our cloud-native monitoring journey. First takeaway is to anticipate the complexity of Kubernetes and its monitoring and have a strategy to deal with it. If you're a team like ours that was new to Kubernetes, there will definitely be a learning curve associated with Kubernetes, how to monitor it, and the open source ecosystem that surrounds it. The second takeaway is that modern cloud native applications require new tools to monitor them. And finally, the third takeaway is that distributed tracing and the auto instrumentation capabilities of OpenTelemetry can be a powerful way to get visibility into the performance of a microservice architecture. Thank you for attending this presentation. I'd now like to hand off to Al.
All right, thank you, Kulwan. Thank you, Derek. Great story and insights. It was a pleasure to have you today with us, and thanks for sharing your application modernization journey with Sumo Logic. I would like to spend some time now to go over most exciting updates to our application observability offering we have delivered since last year's conference. So a year ago, during last Illuminate, we have announced general availability of OpenTelemetry powered distributed tracing and APM in Sumo Logic, and just look at these numbers. Thanks to all of you for your trust and fast adoption. We'll continue to invest heavily in this part of the product and deliver you even more value. So what's next? We're happy to announce 5 great additions to our application observability story, unlocking visibility into single operation performance, as well as real user experience. We have built for you easy-to-use, layer-based AWS Lambda tracing instrumentation support, as well as provided new, unique ways of analyzing APM data in form of span analytics interface and new dashboard panels. Let's dive deeper into these topics. Operational level health metrics describe performance and availability on the level of a single operation, for example, SQL query or API call. Automatically generated from tracing data real time for most active operations, they allow you to understand application service health on one level below. What operation is the service executing towards its peers, and what's the performance of each of them individually? Here, for example, on the screen, we see latency, load, errors for a single type of SQL query on our demo MySQL database. Real user monitoring instruments your user browsers to gather UI performance and user experience metrics like first paint or time to interactive. It allows you to fully understand how your users interact with your application and their experience when doing so. You get insights where the load time is spent. Is it in DNS resolution, or maybe there is a processing delay after the page is already loaded? You can track performance separately per different browsers, operating systems, or geolocations. Drilling down to a single transaction trace level, you can see a browser part here in dark blue, where the user clicked on the button that started a post call to the backend with all timing metrics in the bottom right corner, as well as complete backend trace. Span Analytics applies the power of Sumo Logic query language, intuitive, easy to use user interface, and breadth of information contained in transaction traces. We give you detailed access to your APM data at full fidelity with no sampling to perform most accurate and precise analysis for your custom use cases. Do you want to quickly understand the distribution of custom tag values filtered and aggregated precisely the way you want? Nothing easier, just fill in the required dialogues, pick the visualization type, and hit run. We're also proud to announce general availability of Sumo Logic Lambda layers for distributed tracing. Together with our AWS partners, we'll deliver these managed layers available directly from your AWS Lambda layer repository. Just configure your Lambdas to attach to the layer appropriate for your language and enjoy new visibility in Sumo Logic. Lambda calls appear just as any other spans in your traces, and by clicking on them, you immediately get insights into CloudWatch metrics related to this Lambda and possibility to drill down to dashboards of this particular function. Speaking of nice dashboards, now you can build custom ones with these two new brand panel types, delivering you the views of service map and display pre-filtered list of traces with handy drill downs directly from dashboard panel to trace view screens. So hopefully with these new additions to Sumo Logic application observability, building, operating, and maintaining modern distributed applications will become a little bit easier again. We continue to innovate and deliver even more value, so stay tuned, subscribe to our blog, and get ready for more to come. So thanks a lot for your attention. Once again, thanks to our guest speakers from Pitney Bowes, Kulwant and Derek. Hope you enjoyed the session, and if you have any questions, we'd be happy to answer them in the chat. Thank you.